third topic in chapter 2 is total differentiation, which will be covered in this third lecture. So before going towards total differentiation, we have find the partial derivative of f of xy, that is function f which depends on x and y, and those partial derivatives, that is first order partial derivatives fx and fy, that is dou f upon dou x and dou f upon dou y. So this fx, that is dou f upon dou x, gives a small change in f due to x. Means if there is change in x with x plus delta x, then f changes to f plus delta f. Here y is constant, right? And in second case fy, that is dou f upon dou y, where x is constant and there is only change in y to y plus delta y, due to which this f is changing, which goes from f to f plus delta f. So here we have studied change in a function due to x separately and change in a function f due to y separately. Now what does total differentiation means? Total differentiation means we will take the change in f, that is f is changing from f plus delta f due to change in both x and y simultaneously. Means what does simultaneously means? At a same time. Means here separately x is changing and separately y is changing, where y is constant, here x is constant, right? But total differentiation means we will take change in x and change in y at the same time, and due to this change in x and y at a time, there is change in f as a f to f plus delta f. So if I am saying that there is change in x is from x plus delta x, and if there is change in y from y to y plus delta y, then due to this at a time there is change in the function f from f plus delta f, and this change we can be give as this f plus delta f is equals to this function. F is written as function of xy in this way. Now there is change in function. I am writing that change due to change in x, that is x plus delta x, and change in y is y plus delta y. So this is new function due to change in x and y at a time. Now if we took this f on RHS, we will get f of x plus delta x and y plus delta y minus this capital F. This is equal to delta f. Now if we add and subtract f of x y plus delta y on right hand side, we will add and subtract this quantity on RHS. So let me add and subtract on RHS this quantity. I will get delta f is equals to f of x plus delta x comma y plus delta y. Now firstly I will subtract this quantity x comma y plus delta y, and what is our next term? Here instead of this f I can put f of xy according to this equation. So we have to put here this quantity, that is, now here I will first add this quantity f of x y plus delta y, and what is remaining is that capital F, which is written as f of xy. So if you observe these terms, I will group two terms. I will group this term and then I will group this term. So from our first lecture, in our first lecture, we have defined the partial derivatives. So according to equation 1 and equation 2. So according to these two equations, instead of this first bracket, first we will take this derivative, we will take its with change of this quantity with respect to delta x. Since here this step is missing, we will take first this step and then we will group those terms. So let me take first, I have already grouped, so let me write delta f is equals to first this quantity, that is f of x plus delta x comma y plus delta y minus f of x y plus delta y. Now here I will take this change with respect to delta x. So I will multiply and divide by delta x plus this second term plus what is now second term, this f of x and y plus delta y minus f of xy. Again now this change I will take with respect to y, that is delta y divide and multiplied. Okay. So here on these two terms, instead of these two terms, now we will consider delta x and delta y are extremely small. So if we consider delta x and delta y very small, so instead of delta x I can take it as dx, instead of delta y I will write it as delta dy, and simultaneously delta f is written as df since these quantities are very small. So if we took limit as delta x tends to 0, now if we took limit delta x tends to 0 and limit as delta y tending to 0, so instead of delta f I will put df, and here I will take limit as delta x tends to 0. So here I will get limit delta x tending to 0 of this quantity. So let me write here, I will take limit delta y tending to 0 and I will write this equation, then we will discuss it further. So I have taken limit as delta x tends to 0 for first term and limit as delta y tends to 0 for second term, and I have rewrite the equation for df. This is that equation. Now in this equation, if we substitute equation 1 and 2, so from equation 1 and 2, instead of this quantity which denotes limits, so now here we will change accordingly. So here both quantities, here the function, there is little bit change, you can observe that change. So accordingly we can substitute here dou by dou x and dou by dou y instead of the terms which are written in the limit format. So instead of this term, now this is definition of first order partial derivative of f with respect to x. This is definition, and instead of this delta x, here we will substitute dx and here we will substitute dy, since we have already used here, as those are very small quantity, I can put here instead of delta it as a d, that is small change. So we will use here definition of first order derivative, which is here this quantity is defined as dou f upon dou x at constant y, and here it is dx as it is, plus this quantity in this whole quantity is nothing but dou f upon dou y, which is definition we have already discussed in first lecture, at constant x into this dy as it is. So here, instead of this, in short, we denote first order partial derivative this as fx and this as fy. So let me write on next page, that is df equal to fx dx plus fy dy. So that I will get here df equals to fx dx plus fy dy. Let me call this as equation 9, and the quantity which is expressed in equation 9, that is df, this is known as the total differential of f. Okay. Now it is the total change in f due to small change in both x and y simultaneously. So this is the definition of total differential. Now, if we took f as a function of x, y and z, that is 3 variables, then similar to this equation 9, we can write total differential for this f, which is function of 3 quantities or 3 variables. Those 3 independent variables are x, y and z. So, very similar to this equation, we can find total derivative for this function, which will be here. These two terms will be same, and we will add third term for z, that is fx dx plus fy dy, and third will be fz dz. And this is nothing but equation number 10, that is the total differential for a function which is function of 3 independent variable, where this fx, fy and fz you know very well. So this fx, fy, fz are dou f upon dou x at constant y and z here into dx plus dou f upon dou y at constant z and x into dy plus dou here fz is dou f upon dou z at constant x and y into dz. So this is nothing but the total differential for a function. So now here we will consider a simple case of rectangle. We will take the example of rectangle. So in rectangle there are 2 important variables. One is the length. Suppose length I am denoting by x, and the breadth, that is height or breadth of the rectangle, is given by y. Then function for area f of rectangle depends on this x and y. That means suppose I am taking area of rectangle which is given by f. So area will be product of these two, that is length into breadth is nothing but area. So area f is equal to x into y. Now in this case, if there is change in f due to both change in x and y, means if I have to change the area of rectangle, I have to change this x and y. That is x I am going to change from x plus delta x, and y will be changed from y plus delta y. So ultimately this area will be changed. So this change in area, that is change in f, is nothing but f plus delta f is given by x plus delta x into y plus delta y, both at the same time. We are changing both quantities at the same time. So here if I took this f on RHS, I can write df is equals to, now let me take product, I will multiply, I will simplify these two brackets. So x into y plus x delta delta x y plus here x delta y plus y delta x and minus this f. So what is value of f now? X into y. So xy plus, I will write y, I will slightly change order. There is no change in equation. Meaning is same. So x delta y. And last here there is correction. Delta y into delta x. So here we will get delta x into delta y and minus, instead of f I will put it as x into y. So these two quantities will get cancelled and the remaining quantities are these three terms, that is delta f will be equal to y delta x plus x delta y and delta x and delta y. Now here, since if I took delta as delta x tends to 0 and delta y tending to 0. So here instead of delta I can write d. Since these are very small tending to 0, I can write df is equals to y dx plus x dy plus dx dy. Now this product, this term is very small. So I can neglect this term and I can write df is equal to y dx plus x dy. But you know that what is df? df is fx dx plus fy dy, which is equal to y dx plus x dy. Now if you compare coefficient of dx and dy, this implies me that fx will be equal to y and fy will be equal to x. This means what? Instead of this df, this is nothing but df. So I can write df equal to, in this equation, instead of y I will put fx and instead of x I will put fy. So what I will get? I will get fx dx plus fy dy. And this is known as the approximation. Means if you have to do approximate, so these two quantities are approximately equal. If you solve, we will solve problems, then it will be very clear to you. So let's start problems which are based on the total differential. So we will see problems. So problem based on total differential is given in book, that is problem number 3. Find the total differential of a function f of xy which is given as y is equals to exponential of x plus y, that is e raised to x plus y. E raised to x plus y is written as exponential of x plus y. You know this. Now to find total differential of this function, we have already discussed that total differential df is given as df is equals to fx dx plus fy dy. This is nothing but total differential. So first we have to find fx and fy and then we will substitute in this equation. So fx is nothing but dou f upon dou x at constant y, that is dou by dou x of y into exponential x plus y. Now you should know formulas related to derivatives from mathematics. That is expected. You should know the formulas to find derivative. Now derivative of e to the power any quantity is the same as, suppose dou by dou x of e to the power x is nothing but e to the power x into derivative of x, which is 1. So here what we have to take, so fx is nothing but, here derivative is with respect to x means y is constant, y will be as it is, and derivative of e to the power x is e to the power x into derivative of x. So this will be exponential x plus y, that is derivative of this term, into derivative of x plus y is nothing but 1, because derivative of x is 1 and derivative of y is 0. So multiplied by 1 means same quantity. Now this is our fx, that is y exponential of x plus y. Now we have to find fy, that is dou f upon dou y, which is dou by dou y of y exponential x plus y. Now here we have two functions u into v. So you have to use uv rule. What uv rule tells us, that is d by or dou by dou x of u into v is nothing but u into dou v upon dou x plus v into dou u upon dou x. So we have to use this rule, product rule, which is called as product rule. So fy will be, this is u and this is v. So first u is constant, derivative of v means u is constant, and derivative of v means derivative of this term with respect to y. Itself it will be e to the power x, that is exponential. Here u is now y and derivative of v is exponential x plus y into 1 plus 0, that is 1. So into 1 means same quantity, plus now v as it is, that is exponential of x plus y, and derivative of u means derivative of y with respect to y is nothing but 1, means this is into 1 means same. So we will get fy as this. So if here we took exponential xy common, what we will get? We will get, I am taking exponential x plus y common. So if we took common, we will get here y plus 1. This is our fy. So what will be df? Substitute fx and fy over here. We will get df, that is df is equals to y exponential x plus y into dx, that is our fx, plus what is fy? Fy is this, that is exponential of x plus y into y plus 1 and into this dy. So this is the total differential and solution for problem number 3. Now let's discuss problem number 4, that is find total differential of a function sin beta minus beta sin alpha. Now you should be able to recognize that f is function of here both alpha and beta. You should be able, see here f is sin alpha sin beta minus beta sin alpha. This means what? This f is function of both alpha and beta, means you have to find two terms. Now instead of x and y, we will here variables are alpha and beta. They have changed variable, so don't get confused. Instead of x and y, we are using alpha and beta. So what will be total derivative? Total differential will be df is equals to f alpha d alpha plus f beta d beta. So this is nothing but the total differential. First we have to find f alpha. Now what will be f alpha? F alpha will be dou f upon dou alpha, means derivative of this f with respect to alpha, that is dou by dou alpha of alpha sin beta minus beta sin alpha. I have put a value of f. Now we have to find derivative with respect to alpha. So here derivative with respect to alpha, keeping beta constant, here derivative of alpha is 1 and sin beta as it is, so I will get sin beta into 1, that is sin beta, minus beta is now constant and derivative of sin alpha is nothing but cos alpha. You should know the formulas for derivative. So this is our f alpha. Similarly, f beta will be dou f upon dou beta, that is dou by dou beta of alpha sine beta minus beta sine alpha. I will find very quickly this derivative. So here alpha is constant, derivative of sine beta is cos beta, minus derivative of beta is 1 and sine alpha is constant, that is I will get sine alpha over here. So this is our f beta. Now we will substitute both f alpha and f beta in df. We will get df is equals to f alpha is sine beta minus beta cos alpha into d alpha plus put f beta. F beta is alpha sine beta. No, this is f beta. Alpha cos beta, alpha cos beta minus sine alpha into d beta. So this is our df, that is sine beta minus beta cos alpha into d alpha plus alpha cos beta minus sine alpha into d beta. So this is all about total differential and problems based on it. In this same case, we have little bit studied introduction to approximation. So in next lecture, we will discuss the problems based on the approximate calculations.